In this video, we're going to go through on Nanhua Primary School, Primary 4 Mathematics Term 2 Weighted Assessment 2024. So let's get started. So let's go through on the question 1. So we have a mixed number, and then this looks like we need to convert it into a improper fraction. So what is the mixing number in the box? So I'm going to write down the fraction like this. Okay, so this is a mixed number. So the thing is that if we were to convert a mixed number to a improper fraction, so what do we need to do? So there are two steps to it. So the first step is to have the whole number multiply the denominator. So what is 8 times 9? So 8 times 9 is equal to 72. Right? So now with our number that has been multiplied by the whole number and the denominator, the next thing is to add this to the numerator. So what is 72 plus 5? It is 77. So now we know what is the improper fraction for 8 whole number 5 over 9, which is 77 out of 9. So let's see what's the option. Option 4 is 77. So the answer is 4. All right. Let's move on to the next question. Question 2. In the following figure, how many of the marked angles are obtuse? So what is obtuse? So there are two parts to obtuse. The first one. So the first part of an obtuse is it an angle that is more or less than 90 degrees? If you say that an obtuse angle is more than 90 degrees, then you're right. So the answer is more. So I can erase this, right? Then the second part over here is obtuse angles more or less than 180 degrees. If you say angles it is less than 180 degrees, then you are right. Okay. So now this figure below, we have 1, 2, 3, 4, 5 angles. So the marked angles means what are the angles that is marked with this little part of a circle. Okay. So what I'm going to do is I'm going to use my ruler over here to basically use this corner or any parts of the corner of the ruler to just check whether it is more than 90 degrees. So I think the first angle that I'm going to look at is this angle. And obviously this doesn't look like an angle that is more than 90 degrees. So what I can do is I can just put an X here, right? So I'm just going to put this over here, X, no. All right. So now let's move on to this angle. So I think the easiest is to see using your ruler. You can check whether this is a right angle as what you see over here. Okay. So I'm gonna resize this and see whether this is more than 90 degrees. So you can see that if I were to, because the corner of your ruler is actually more than 90 degrees. So if I were to put it close like that, you could see, if I were to zoom in, that it is more than 90 degrees because there's additional space over here. So then that means this is a correct one. Okay, obtuse angle. All right, let's move on to the next one. So the next angle is this angle that we want. So I'm going to move my ruler to the angle over here. Oh, it looks like a right angle over here because my ruler is almost exactly how it looks like. So sadly, this is not an obtuse angle, but a right angle instead. Okay, I'm going to move my other ruler just to this side over here. Okay, so I'm going to move it here. And if you look closely, there's actually some little space over here. So since there's some space, that means this is a obtuse angle. And then the last one, if I were to move this ruler, okay, let me just move this over here. Okay, and you can see there's also still a few more space over here. So that means this is also a obtuse angle. So that means we have a total of one. So one, two, and three angles that are more than 90 degrees. And that means the answer for this is number 3. All right, let's move on to the next question. Question 3. Measure AOC. So I'm going to highlight what AOC is. So this is A, O, and then this is C, right? So when the line, first thing is that when the line starts at either end, right? So if it starts at AO, which is on the left, then we're going to measure from 0 over here, okay? This is 0. So we can ignore this 180 and we just focus on this part of the protractor over here, okay? So now if we were to look at OC over here, then what we need to see is this whole, I would say, let me highlight another color. So we're just going to focus on these numbers until we hit the number over here. And this number, you can see that it is, if I were to zoom it in, it is 110 degrees. That's what I see over here. So that means this is 310 degrees. All right, let's move on to the next question. Question 4. In the letters below, how many letters have more than 2 right angles? So right angles are basically this corner of a right angle. That's what you see over here. Okay. So we're going to go through every single letter. So you can also remove some letters that we can ignore because some letters are repeating. So the repeating letters, do we have any repeating letters? Actually, not really. Okay, never mind. So scratch that. Okay, let's look through to the letter M. So I'm going to zoom this in. Right, letter M. Do we see any right angle? So there is this angle over here, there is this angle over here, there is this angle over here. But all of these angles are not really right angle, so we can ignore this and we can just create an X. Let's move on to A. So let's see if we have any angles. This is not a right angle, this is not a right angle, this is not a right angle, and this is not a right angle as well. So sadly, A also does not meet our requirements of more than 2 right angles. So let's move on to T. So T over here, you can see that there are 2 right angles. Can I zoom in even more? Okay, this is my max. So T, there is one right angle over here. And okay, let me have another one. So this one, so one right angle and then another right angle. I'm going to make it a little bit different like this. So there are 2 right angles. But what is the question asking? More than. So there is this word more than. So that means it is either 3, 4, 5, or 6 right angles. But we only have 1 and 2 right angles. So that means, sadly, this does not meet what the question is asking. Let's move on to H. H over here, actually, let's see. There is 1 right angle. There is 2 right angle. There is 3 right angle. And then there is 4 right angles. So is this more than 2? Of course it is because we have 4 right angle. So that means this, we choose another color. This is correct. Okay, let's move on to I. Sadly, I is just one straight line over here. So just one straight line. So this is a no. For an S, I like how it looks like, but there is no straight line to create an angle. So S is not stated. Okay, F. What do you think F is it? Does it have more than one? I mean 2 right angles? So let's see. So we have 1 and we have 2. Is that it? We actually have one more, which is here. 3. Okay, right? So we have 3, and does it meet this requirement more than 2? Yes, it does. So we're gonna put this as correct. So U, sadly, there's no, I mean, there is a straight line, but it's also curved, right? It's curved. So sad life, no. Sad life, no. So this, no. And N, we do have straight lines. But the thing is that the angles over here is not 90 degrees, right? So sadly, this is not it. Okay, so now if we were to zoom out over here, how many letters do we take over here? So there is 1, which is H, and 2, which is F. So the answer to question 4 is 2. There you go. All right, let's move on to the next question. Question 5. All right, so question 5. Arrange the following fractions in increasing order. So we have 19 over 6, 3 whole, 6 over 7, and then 29 over 9 as what we see over here. So in this case, first thing is we need to know what increasing order means. So increasing means from smallest, right, to biggest. Okay. So we have this fractions, 19 over 6. Then we have 3, 6 out of 7. And lastly, 29 over 9. So what we're going to do is, since all of the numerators is more than except for this, since the other two fractions, that is improper fractions, are have their numerators more than their denominators, then we're going to make it into mixed numbers. So for 19 over 6, if we were to divide it, it will be 3, because it's 18, 1 over 6. Okay, then this is already a mixed number. So 3, 6 out of 7. And then lastly, this comma, 29 out of 9. So the closest is 27. So 3 times 9. So 3 whole number. Then this is 2 out of 9. Okay, so first thing is we know that all have the same whole number. But one thing that we can do is that we can realize that if we were to compare their fractions, if any of the fractions has a numerator that's very close to the denominator, which is this 3, 6 out of 7, we can know that this is actually the biggest fraction. Okay, because it is very close to having all of their parts to a denominator. So 6 out of 7 is literally, like, you could say it's very close to a 7. So we can definitely say this is the biggest. Because you see the other two fractions is like 1 out of 6, which is pretty low, and 2 out of 9, which is also pretty low. So now with that, we can see this should be at the last part, right? So this should be at the, since this is an increasing order, which is smallest to biggest, so the biggest should be 3 out of 6, 7. And we see there is two options over here. Now the next part is we want to compare we want to compare the 3 whole number 1 over 6 and 3 whole number 2 out of 9. So we want to get the common multiple. So what is the closest common multiple that we can get? So we have 6 and we have 9. So let me just draw a line so that at least this looks a little bit nicer to see. So we have 6, 12, and then we have 18, and then we have 9, and we have 18. So you could see that 18 is the lowest common multiple. So what we can do is we can have 6 and make it into 18. So times 3 over here, and then times 3 over here. So this will be 3 out of 18. And then the other one is 3. Since this will be times 2, and then we times 2 over here. So this is 3, 4 out of 18. So now we can compare which one is the smallest. So the smallest one is actually 3 1 over 6, which is this case, because it is 4 of 18. This is 3 of 18. So this is smaller than this one. So this means this is the smallest. So That means 19 over 6 over here is the smallest, and 3, 6 out of 7 is the biggest. So from there, you can see 19 over 6 is the smallest, 3, 6 out of 7 is the biggest, which that means that the answer is number 3. Let's move on to the next question. Question 6. The table below shows the number of primary 4 students who can swim in a primary school. Sad life, I mean, I'm not very good at swimming. There are equal number of students in 4A, 4B, and 4C. Which of the following shows the correct data for A and B? So we have people who can swim and people who cannot swim. And one thing to know is that there are equal number of students in all of the classes. So let's go and see what is the total over here. So we can actually add another little row over here. So we have a total. Okay, so okay, that's not it. But okay, I'm just gonna make it a straight line as what you see over here. Okay, total. Yep, 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 yep. Okay, so 28 plus 8 is equal to 36. So now we know that every class has a total of 36 students. So that means if we have all the total is 36 and 36, that means from the total we can get each individual, I would say row over here. So for 4B over here, 4B is basically number of students who cannot swim is 36 total minus 16. Because we have 16 over here. And this gives us 20, right? Then for 4C, we have 14. So we can just minus the total. So 36 minus 14. And this gives us 22 or 22. So that means for A, it is 20, right? And then 4B is 20 and 4C is 22. So A is 20, B is 22. So in this case, answer or option 2 has A as 20 and B as 22. So we can put here 2. So the answer is for question 6 is 2. Right. Let's move on to the next question. So now we are at section B. So question 7. What are two other ways of naming angle B? So angle B is over here, right? So we can ignore angle A. So what I'm going to do is I'm just going to make this white and just going to color this and ignore this over here. So let's focus on angle B. So how do we name? So the name is basically how do we describe using the different points over here. So the first part is D, B, and C. So let's write that down. So this is D, B, and C. And the second way is the opposite, C, B, and D. That's it. So it's C, B, and D. All right. Pretty straightforward. Let's move on to the next question. Question 8. All right. It says here, draw the angle with a given line. Mark and label the angle. All right, so RQS is 135. So what that means is we need to draw a line from R and Q. So we can ignore P and we just focus on R and Q. So first is that I'm going to draw the line over here. See if it's very visible. So I'm going to draw a line from R and Q. And then after that, we're going to look at 135. Okay, so how do we get 135? Since we are putting the angle, the line over here, so we're going to concentrate only at the lower part of the protractor. So I'm just going to highlight so that we can focus on the lower part. So which is 0, 20, 30, 40, 50, 80, and then 100, 120, and 130. So then we need to know what is 135. So we're going to zoom this in. All right, so there is a halfway point between 130 and 140, right, which is the middle over here. Yeah, it doesn't look very nice, but basically what I'm going to do is I'm just going to draw a straight line to my point. So another thing that I recommend you to do is to actually have another line over here, so that when you connect the lines, it's actually more accurate. So now I'm just going to draw this in between 130 and 145, and this will straighten out to do like this. And after that, you can like erase this a bit, and there you go. This is 135 degrees. That's what you see over here, right? And then the last part is you also need to label you need to mark the angle. So it should be RQ and then S. So you need to write the word S over here. So let's put an S, and that's a nice S. And then we're gonna draw the 135 over here. And then I'm just gonna put this. Oops. Okay, I'm just gonna draw the semicircle like this lah, right? And then I'm gonna put 135 degrees. That's what I see over here. And that is how you mark and label the angle, as what you see over here. Right. Let's move on to the next question. Question 9. Express 74 out of 8 as a mixed number in its simplest form. Okay, so what we can do is basically I'm just going to write down 74 out of 8. And how do we make it into mixed number? So you have 74 divided by 8. Okay, so what you can do is you can get the closest to 74. What do you think is the closest to 74? 72. So what gives 72, which is 9? 9 times 8 is 72 and gives us the remainder 2, right? So the quotient is 9 and the remainder is 2. So usually for any quotient where you are dividing, so this is the quotient. So the quotient is also 9 over here. Okay. Then we put the remainder at the top over the denominator, which is 8. And this remainder over here, I'm going to put another color. I'm going to put this blue. So 2 over here. This remainder, we're going to put it over here. So first is the quotient is 9, which is our whole number. Second thing is the remainder is 2. So the answer is 9, 2 over 8. But then it says here simplest form. Can this be simplified as well? Yes, you can. So what can 2 and 8 divided by 2? So if you know the answer, it can be divided by 2, since the numerator can also be divided by 2. So the answer is 9, 1 over 4. So this is the answer. 9, 1 over 4. All right, so let's move on to the next question. Question 10. What is the missing number in the box? We have 6 and 9, and suddenly it becomes 15 and something else. So how do we get into 15? Okay, so I would say first step is to simplify as much as possible to this initial number as what you see over here. So 6 and 9, 6 over 9. Can we simplify it? Yes, we can. We can divide it by what is the common factor between these two? The answer is 3. So we can divide by 3. So this will be 2 out of 3. So can 2 out of 3 be something over 15? Yes, we can. So how do we get from 3 to 15? What do we multiply with? If your answer is 5, you are right. So we can multiply 5. And then for 2, that means we also multiply by 5. And what is 2 times 5? 10. So the answer to the missing number is 10, right? Don't put the whole fraction. Just put the number because it's asking for the missing number. Let's move on to question 11. So section C over here. Question 11. Peter had 48 apples. He used 2/3 of them to bake a pie and 1/6 of them to make apple juice. How many apples did he use? So first is, I would recommend is to actually add the two fractions, 2 out of 3 and 1 out of 6. So fractions of total use, right, total used is basically 2 out of 3 plus 1 out of 6. So I think pretty straightforward. The 3 over here, we want to make it the same as 6. So we can just multiply by 2. That means we multiply the numerator by 2 as well. This will be 4 out of 6 plus 1 over 6. And this will give us 5 over 6. So basically, apples used, you can just multiply, right? So you have 48 times 5 over 6. So what is this? 48. So you can have 48 divided by 6. This will be 8. What is 8 times 5? This will be 40. So the answer is 40, right? So you can use units as well. So another way is you can just say the total units is 6 units, which is equal to 48. And then you get 1 unit and you multiply by 5. Similar to this as well. Let's move on to question B. How many apples were left? So pretty straightforward. We have 48 minus 40 because we have apple use, which is 40, and then also total apples 48. So what's 48 minus 40? The answer is 8. All right, very good. Let's move on to the next question. Question 12. A car was filled with 45 liters of petrol. The car started traveling from 0800 hours to 1400 hours. Petrol was used when the car was moving. The line graph shows the amount of petrol from 800 hours to 1400 hours. Question: how much petrol was used from 900 hours to 1100 hours? Okay, so one thing to know is that for petrol, right? Imagine you start off with, for example, 100 liters, maybe at, for example, 0800 hours. And then it says here it is 90 liters, and this is 0900 hours. So this is just an example. So this is example, right? So that means how many liters has been used. So basically from 800 to 0900, right? So how many liters has been used, which is basically 10 liters has been used from 0800 to 0900 hours. Okay, so that means we need to first get the number of liters from 0900 and 1100. Okay, but first we need to know how much or what's the value of the lines, or what's the number for the lines. Like for example here, so usually to count how many is from one number to another number and what's the line in between, you just need to count the number of lines. So we have 1, 2, 3, 4, and 5, and then the difference is 5, right? 20 to 15 is 5. So that means we can say this is 16, 16, this is 17, this is 18, this is 19, and this is 20. That's what you see over here. Okay, so that means one line is just one, right? So now the next thing is we need to just get the the petrol use at 900 hours to 1100 hours. So 900 hours, you could see if we were to zoom it in, 900 hours. Okay, so we have 9 a.m. So let me just use this. So 9 a.m. over here is actually, let me use a red line. It's over here. So this is one line above 40. This will be 41. So for 900 hours, this is 41. Oops, 41. And then after that, for 1100, I'm going to draw this one line. And then we're going to draw from the dot all the way to 31. That's what I see over here. So this will be 30. So 30 minus 1, this will be 29. So 1100, this is 29. So now we just need to minus, basically. So we can just put here 41 minus 29. And this returns us, what's the result? This is 12 liters. Okay, so we can just put here as 12 liters. That's what you see over here. Right, the next one, question B. At which 1 hour period was the car not moving? Okay, so if you look at the graph, there is one period that the car was not moving. Can you guess which one? So, if the car is not moving, are we using any petrol? Probably not. So, one thing you could see is that there was one point where it was not moving, which is from 11 a.m. to 12 p.m., right? Or 1100 hours to 1200 hours, right? So, if you're not using any petrol, that means the amount of petrol didn't change at all, right? So, that means for the period of 1100 hours, to 1200 hours. So that is where the car was not moving. Okay. All right. So let's move on to question 13. So question 13 says here, John used 310 of sugar to bake a cake. He used 1 4 kilograms of sugar less to make jelly than to bake a cake. And then he had 1 over 4 kg of sugar left. So how much sugar did he use for the jelly and cake all together? So first is we need to calculate the jelly because we already know how much sugar we use to bake a cake, which is 310, but we don't know the jelly. So first, let's write down jelly. Okay, so jelly, sugar. Okay, I'll just put jelly first. So jelly. So he says over here he used 1 4 kg sugar less to make a jelly than to bake a cake. So that means the sugar to make the cake is 310 less minus and then 1 over 4. Okay. So we also need to know what's the common multiple between 10 and 4, lowest common multiple or smallest common multiple. So you have 10, you have 4. So what's 10? It's 20. 4 is 8, 12, 16, and then 20 as well. Okay. So that means from 10 to 20, we need to, right, minus out 20. So we have 20 for 10 and 4 for 20. So that means we need to multiply by 2 and 4 we need to multiply by 5. So for 3 out of 10, the 3 numerator we need to times 2, and then for 1 out of 4 we need to multiply the numerator 1 to 5. So that gives us 6 out of 20 minus 5 out of 20. And for jelly, it gives us 1 over 20. So now what's the total? Or basically jelly and cake, which is basically 1 over 20, right? Oops, plus 3 out of 10. So pretty straightforward, the lowest common multiple for this will be 20. So 3 out of 10, we times 10, the denominator times 2 to get 20. And then 3, we also multiply by 2. So 1 over 20 plus 6 over 20. And this gives us 7 out of 20. So that means the answer over here is 7 out of 20 kilograms. Let's move on to the next question. How much sugar did he have at first? All right, so we know that he used 3 out of 10 kg, and we add up the jelly, which is 120, 1 out of 20, which gives us 7 out of 20, right? And then he had left 1 out of 4 kg. So what we need to do is just add uh, what he used and what he has left. So what he used is 7 out of 20 plus what he has left is 1 out of 4. So straightforward as well. The lowest common multiple is 4. Multiply by 5. And then for the numerator, we multiply by 5 as well. So 7 out of 20 plus 5 out of 20. And this gives us 7 plus 5. It's 12 out of 20. And we can simplify. So what is the, I would say, factor between these two? Common factor it is, if you guessed it, we can divide by 4, we can divide by 4 as well. So 12 divided by 4, 3, 20 divided by 4, 5. So the answer is 3 out of 5 kilograms. So you see over here. So you simplify your answer. And that's it for Nanhua exam paper.